Hi Minima team. Adam, Hugo. This is primarily for you, to give you a better understanding of my project. I know today's call didn't happen, so I put this video together to make sure you have everything you need ahead of tomorrow, rather than waiting another day to share it. I'll walk through a live demo of the current MiniDapp, show you the website, recap where the project stands, cover a few new details on certification, and lay out a concrete proposal for how we could structure the grant. If anything's still unclear after this, just let me know what's missing, and I'll follow up directly. Let me show you what the Trackium MiniDapp looks like right now. This isn't the latest version, the next update isn't fully ready yet, but it already gives you a clear sense of how it works. I'll launch the Minima node on the device and log into the MiniDapp. From here, I go to the My Devices section to add a new device. I fill in the required fields. The most important one is the unique device ID, which you can copy right away during registration. Once that's done, the registered device shows up, at first with an offline status. Next, I go to the Trackium companion app on the same device and enter that same device ID. Then tap Start Tracking. Back in the MiniDapp, I refresh the data, and now the device shows online with current coordinates and movement updating every 3 minutes. In the shipment section, you can also add a specific route and track the device's movement against it to confirm it's staying on course. And here, I can manage the tamper-proof cable directly, arm or disarm it, and generate a temporary QR code for authorized personnel. That's the current MVP, running on an Android phone as the test platform rather than the final hardware. The next version, which is about 70% complete, is a significant step up. Cleaner UI, live route tracking with deviation alerts, subscription management, and a mode selector, so the same MiniDapp works either as a lightweight single device view or a full fleet manager dashboard. It's also being optimized specifically to pair with the final Trackium hardware, rather than an Android phone as the sensor source. Let me remind you of the MiniDapp operating principle for data exchange with the current test device, Android smartphone. The Android app receives the device's coordinates and stores this data locally on the device. For this purpose, Android provides a local server. This data is available as JSON. MiniDapp accesses a local HTTP API and receives JSON with latitude, longitude, battery, timestamp, and other status fields. This data is updated every 3 minutes, and Trackium MiniDapp collects it. Afterwards, the location information and map are updated on the home screen, the screen of the specific device, and the cargo route screen if a route has been added. You can also make an additional request for the current location and update the data at any time without waiting for the next 3 minutes. Each device consists of hardware running a Minima node and the Trackium MiniDapp. Here is how it works. A logistics company manager purchases any number of devices and activates them, configuring the MiniDapp and registering each device to obtain a unique ID. The manager can then add all these devices to their node in one place, allowing for convenient monitoring and management, such as locking or unlocking smart locks, verifying route adherence, generating additional blockchain proofs, and more. Let me also show you the website. Technology, device, dashboard, pricing, use cases, about pages. It's grown from a small landing page into a full multi-page site. The technology behind Trackium, the hardware itself, real use cases across land, sea, and air logistics, pricing, and the roadmap. If anyone on your side wants to dig into the technical detail at their own pace, this is the best place to do that. Quick recap of where things actually stand right now. During the Edge Pioneers program, I built an MVP validating the core idea end-to-end, device location and battery tracking, with an Android companion app feeding GPS and battery data to the MiniDapp through a local API, polled every 3 minutes. Automatic or on-demand blockchain proof of movement is already built in. Onboarding is simple, as you just saw. Register a device, pair it with the companion app, and it goes live with location, battery, and movement history. On hardware, the architecture is fully locked. The core is a Raspberry Pi 02W with an LTE Cat-M1 NB-IoT module, a SIM7000E for independent connectivity that doesn't depend on a paired phone, a high-precision GPS module, a LiPo battery with solar charging, encrypted communication with the Minima node, and a physical tamper detection cable with remote arm disarm and temporary QR access. It's built on a modular sensor platform: temperature, humidity, vibration, shock, tilt, and others. So the same core platform can serve different industries without a redesign. One thing I want to flag directly, since it's new since my last update. Before running real pilots across Ukraine, the EU, and the UK, the device needs baseline regulatory certification. This isn't optional. It's legally required to operate across those borders. Specifically, CE certification for the EU, which, as of this year, the UK also recognizes indefinitely for radial equipment and electronics, so one certification process covers both markets. Ukraine has its own separate radio equipment certification process, though using already certified components lets me reuse a lot of that CE test data and keep the extra cost small. And, separately, the LiPo battery needs UN 38.3 certification, which is mandatory for international transport of lithium batteries by air, sea, or road, regardless of destination. Altogether, using pre-certified components to keep costs down, this runs roughly $3,100 to $3,500. Lab testing, documentation, and a compliance consultant to make sure all three jurisdictions are handled properly rather than risking a pilot getting stuck at a border. I wanted this fully transparent upfront, since it's a real, concrete cost that sits outside simple component pricing. Before I get into the milestone structure, I know the exact amount is still being finalized on your end, so I won't guess at a number here. What I'd say is that what would make the most sense to me is whatever was originally discussed as the total pool for the Edge Pioneers program, split across the 3 winning teams. Whatever the final amount ends up being, I'd like to propose splitting it into milestones rather than a single payment. I think it makes the process transparent and easy to track progress against. I have 2 structures in mind, and I'm flexible on which one, or some adjusted version of either, works best for you. Option A, 2 milestones, split evenly. Milestone 1, paid up front, roughly 2 months. Build the working Trackium prototype across all 3 core environments: land, sea, and air-capable modular configurations, including multiple component iterations, enclosure development, and internal bench testing to pick the most reliable setup for each. Deliverable: 1 working device per configuration, plus a demo video. Milestone 2, paid on completion, roughly 2 to 3 months. Real-world field validation, deploying the built devices in actual operating conditions, a real truck route, a container or vessel, a drone flight, over a meaningful period, plus feedback or confirmation from at least 1 external pilot partner. This stage is also where the certification work I just covered happens. Option B, 3 milestones, split evenly. Milestone 1, paid up front, roughly 2 months. Base device plus land configuration. Component sourcing, first working prototype, enclosure development, internal bench testing. Milestone 2, paid on completion, roughly 1 to 2 months. Sea and air modular variants completed. Integrated field testing across all 3 environments in real conditions. Full demo video. Milestone 3, paid on completion, roughly 1 to 2 months. Real-world pilot deployments with external partners, outreach to logistics, shipping, and drone companies, groundwork for commercial rollout, and this is also where the certification work sits. Either way, I'd ask that whichever milestone comes first be paid in full upfront, rather than partially or reimbursed. That's really about iteration risk. I need room to build a few different hardware combinations and pick the one that performs best, and that's hard to do if funding only arrives against receipts after the fact. On proving each stage is actually done, I'd suggest we define clear deliverables up front for each milestone. A demo video showing the device working in each environment, field test data, and for the pilot stage, confirmation from the partner company itself. Happy to agree on the exact criteria together, so it's clear and verifiable on both sides. Looking ahead, different hardware configurations by environment. Land, sea, air, and rail later, each with its own enclosure and sensor package. Testing itself happens in stages. Personal testing on real routes, then pilot deployments with logistics companies, then commercial rollout. Targeting first paying customers by late 2026 or early 2027. I'll say this directly. This is my first commercial hardware product, but I'm deliberately reducing that risk through incremental development, validating each stage before committing to the next, rather than jumping straight to manufacturing. That's really the thinking behind the whole milestone structure I just walked through. That's the full picture: the working MVP, the locked hardware architecture, the certification requirements, and a concrete proposal for how to structure the funding. If there's anything still unclear, or anything else you need to make the call on this, just let me know directly, and I'll get it to you as fast as I can.